Let's start with authentication and authorization. In this first lesson, you will learn about how user and service accounts work in Kubernetes. You'll then learn about how to create and manage those accounts in GKE. In Kubernetes, there are two main types of users: normal users and Kubernetes service accounts. Be careful here. Both Google Cloud Platform and Kubernetes have an entity called a service account, but they're not the same. I'll explain the difference in a minute. For now, keep in mind that your day-to-day focus will be on normal users. Normal users are managed outside of Kubernetes. That is, Kubernetes relies on external identity services. That's true both in Kubernetes clusters that you build yourself, as well as in those GKE manages for you. When you use Kubernetes clusters in GKE, you'll define most user accounts through Google's identity service. Informally, that encompasses the consumer Google accounts that you're familiar with, plus accounts in G Suite domains. If you don't have a G Suite domain, you should get a Google Cloud Identity domain for your business, which is at no additional charge in most circumstances. A Cloud Identity domain gives you much more organizational control than using consumer Google accounts for all of your employees. All these kinds of accounts together make up Google Cloud Identity. We use the word member to refer to each individual identity defined by the service. It's a flexible service. It lets you define user identities directly or mirror them from your existing directory service, such as Active Directory. It also lets you group users, which turns out to be the key part of an important best practice I'll tell you about later in this module. GCP's Cloud Identity and Access Management Service, or Cloud IAM, is where you bind permissions in your GCP project to members. And then you need to tell Kubernetes about the members you want to give permissions inside your clusters to. Any Cloud Identity member can be configured as a normal user in GKE Kubernetes clusters. In contrast to normal users, Kubernetes service accounts are accounts managed by Kubernetes. Kubernetes service accounts provide an identity for processes in a pod and are used to interact with the Kubernetes cluster. These are different from GCP service accounts. Those are managed by Google Cloud Identity, not Kubernetes, and you use them when you want GCP resources to have an identity that's tied to an application or a virtual machine, not a human being. You can even configure GCP service accounts as a normal Kubernetes user if that proves necessary. In Kubernetes, every namespace has a default Kubernetes service account. When processes in containers within a pod communicate with the Kube API server, they identify themselves as a Kubernetes service account. If you're security sensitive, you might be worried about these Kubernetes service accounts. What if an attacker compromised a container or a pod? Could they grab service account credentials and then use them in further attacks? Yes, they could. In Kubernetes 1.8 and higher, thanks to the implementation of RBAC, service accounts have no default permissions or access tokens. GKE only supports the last 3 minor versions of Kubernetes, so if you're running on GKE, you already have this enabled. You don't have to worry about this potential problem. After an account is authenticated, for example, a user authenticating via Cloud Identity, there are 2 main ways to authorize what that account can do. 1, Cloud Identity and Access Management, or Cloud IAM, and 2, Kubernetes Role-Based Access Control, or RBAC. In fact, you need both controls. Cloud IAM is the access control system for managing GCP resources. It lets you grant permissions to users to perform operations at the project and cluster levels. In other words, outside your Kubernetes clusters. On the other hand, Kubernetes RBAC gives you access control inside your Kubernetes clusters at the cluster level and the namespace level. It lets you create fine-tuned rules and granular access to resources within the cluster. So you'll use Cloud IAM to define who can view or change the configurations of your GKE clusters, and you'll use Kubernetes RBAC to define who can view or change Kubernetes objects inside those clusters. With both of these methods, it's a best practice to exercise the principle of least privilege. Each person who has access to your cluster should have the minimal set of permissions to do their job. In Kubernetes, the API server listens for remote requests using HTTPS on port 443. Each request must be authenticated before it's acted upon. The API server can perform this authentication using various methods. GKE supports, as authentication methods, OpenID Connect tokens, X509 client certs, and basic authentication using static passwords. OpenID Connect is a simple identity layer on top of the OAuth 2.0 protocol. It lets clients verify the identity of an end user by querying an authorization server. The clients can also get basic profile information about the end user in an interoperable way. X509 client certificates and static passwords present a wider surface of attack than OpenID. Unless your application is using these methods of authentication, you should disable them and use the OpenID authentication method instead. In GKE, Both X509 and static password authentication are disabled by default in clusters created with Kubernetes 1.12 and later. This helps improve the default security configuration.